Hey everyone, welcome back to Sajguru's Talk. Today we are going to discussing about SJF scheduling algorithm. Now, SJF scheduling algorithm is nothing but shortest job first scheduling algorithm. It is one of the CPU scheduling algorithm where the process with the shortest burst time is executed first. It is also known as the shortest next CPU burst scheduling. Generally, the SJF algorithm can be categorized into two types. One is non-preemptive version and the preemptive version. A non-preemptive SJF means what? Once a process starts execution, it cannot be interrupted until it finishes. Whereas preemptive SJF, or in short, otherwise we can call it as SRTF, shortest remaining time first. The CPU is assigned to the process with the shortest remaining burst time. If a new process arrives with the shortest burst time, it preempts the currently executing process. We shall see the working principle of SJF algorithm by taking a simple example. Here, the three processes P1, P2, P3 and appropriate burst time and arrival times are given. So let's get started its working principle. First, we need to identify all the processes with the current time. Now we need to choose a particular process with the shortest burst time. Now execute the selected process until its completion. Why? Because it is a non-preemptive version. Now for the step 1, we need to sort all the arrival times. So the table looks like this. The second step, we need to create the Gantt chart, which is the visual representation of process execution. Now, there are three different type of processes, so three columns. At the 0th millisecond, process P1 arrives and it executes for 6 milliseconds. Now, among the 6 milliseconds, which is having the shortest burst time, P3. P3 arrives at 4 milliseconds and has the shortest burst time than P2. So it executes next. Now P2 executes last as it has the longest burst time. So, and it executes for how many seconds? 8 milliseconds. Now, the 9 plus 8 is nothing but 17. Now we should calculate the completion time of all processes. The process P1 completion time is 6 milliseconds, process P2 completion time is 17 milliseconds, and process P3 completion time is 9 milliseconds. In the third step, we are going to calculating the turnaround time. What do you mean by turnaround time? The time it takes to complete a process or task from start to finish. And we know the formula for TAT is nothing but completion time minus arrival time. Now the table looks like this. So it is TAT. Process P1 TAT is 6 minus 0, that is 6 milliseconds. Process P2 is 15 milliseconds. Process P3 is 5 milliseconds. In the step 4, we are going to calculating the waiting time. Waiting time is a differentiation between turnaround time minus burst time. Now, the waiting time is calculated in such a way this. The last stage, we are going to calculating the averages. So, average turnaround time is the summation of TAT by number of processes, and average WT is the summation of WT by number of processes. Now, so what are the advantages of SJF? It minimizes average waiting time and provides better turnaround time compared to other scheduling algorithms. Now, what is the disadvantage? Starvation and difficult to predict burst time. What do you mean by starvation? Longer processes may have to wait indefinitely if shorter jobs keep arriving. And the second disadvantage, accurate burst time estimation is required for optimal scheduling. Now, so generally this SJF scheduling algorithm is used in batch processing systems where burst time can be estimated. Suitable for short interactive tasks where the quick response time is needed. In short, SJF is an efficient scheduling algorithm that minimizes waiting time but may cause starvation. Thank you for watching. Please subscribe for more videos. Thank you.